Hello friends, in this lecture we will see here the Mho relay. So the Mho relay, it is similar to that the induction cup type of the structure. It again produces the two torque, operative torque and the restraining torque. Operative torque produced by the voltage and current element and restraining torque produced by the voltage element. It is also called as the admittance relay. These relay are used in the long transmission line, medium transmission line and the short transmission line. But the working principle of Mho relay, it is used for long transmission line because these lines are generally experience power swinging transient as well as the load shedding problem. So the Mho relay is a voltage restraint directional relay. So you will get the MCQs. Mho relay is dash 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 directional relay. So your answer is voltage restraint relay. Then second question is there, Mho relay. Which transmission line we are using for the Mho relay? The answer is it is used for the long transmission line. Again, the third MCQ is here. Mho relay, it is also called as the admittance relay. So, what is the Mho relay? Mho relay is referred as a voltage control directional unit, directional relay, or the admittance relay, or the high speed relay. This is the name for the Mho relay. So, the operating torque can be determined by the voltage and current element, and the voltage element develops the controlling element. This type of the relay are used to detect phase fault for long transmission line at the point where there is the occurrence of the synchronizing power surges also. So the more relay is the more sensitive and reliable because it is combined unit of the both the distance measurement and the direction. This is the simple diagram for the Mho relay. So it is again similar to that the impedance relay. It is not normally used because need of the separate directional unit, and in this relay there is a no separate directional unit. So this type of relay are normally used. So it is again the working principle. It is similar to that the impedance relay. It is made up of the directional by providing the polarizing winding. This is the polarizing coil. Um, so the torque produced is polarizing fluxes from the opposed voltage and current. Oppose the voltage and current. That means the current and voltage poles. So where is the current and voltage pole? Pole number 2 and pole number 4. That means the operating coil and the restraining coil. So this is nothing but we have in this Mho relay produce the two torque, operating torque and the restraining torque. So in this relay we have to see here the it is depending upon the impedance relay and the directional element. So this structure, it is again similar to the induction cup type of the relay. It has a polarizing coil, it has a operating coil, and it has a restraining coil also. And the polarizing coil, we have to connect the pole number 1. It is series with the inductance and the series tuning capacitance with the inductor. We have to connect with the restraining coil. That means pole number 1 to pole number 4, and we have to connect with this pole. Connect with this pole. So if the measurement is lesser than the final impedance, if the measurement is lesser than the final point of the impedance, that means then it is we can say that if the impedance measure is lesser than the final point impedance, then it is considered as the fault that exists on the line in between the relay and the final point. Okay, relay and the final point. So this is the structure of the relay. But when the fault occur, when the we have to measure the impedance, so impedance is lesser than the final point of the impedance, then it is considered as the fault exists on the line between the relay and the final point. The interaction of the fluxes due to pole number 2, pole number 3 and the pole number 4. it produces the operating torque. And pole number 1, pole number 2 and the pole number 4, 1, 2 and the 4, it produces the restraining torque. It produces the restraining torque. So this series capacitor you have to connect it to provide the action. That means जो आपका restraining torque produce होगा तो ये proportional करेगा. That means it is proportional to the V square. Okay, it is proportional to the V square in this case. So that we have to connect here the series capacitor. This is the series capacitor. So while operating torque is proportional to the product of the voltage and the current. Voltage and the current. That means this operating coil, it produces the operating torque and it is proportional to the product of voltage and current. So यहाँ पे जो तीन टॉर्क प्रोड्यूस हो रहे, विच आर दे? फर्स्ट इज द स्प्रिंग टॉर्क, सेकंड इज द ऑपरेटिंग टॉर्क एंड थर्ड इज द रिस्ट्रेनिंग टॉर्क. ऑपरेटिंग टॉर्क, restraining torque and the spring torque. So this spring torque we have to neglect it. Okay, we have to neglect it. So restraining torque is proportional to the V square. Let's see, we have to see the torque equation. So there is the torque equation. So according to this torque equation, it is proportional to the voltage and current, while the restraining torque is proportional to the V square. That means there is produced the two torque, operating torque and the restraining torque, and spring torque we have to neglect it. So this is the operating torque, K1 VI cos theta minus tau. Then K2 V square, this is the restraining torque, and K3 is the spring torque. So this control spring effect we have to neglect it. So when we have to neglect it, then we get the balance torque equation. Net torque is 0. So we have to consider T equals to 0 and we get the K1 VI cos theta minus tau K2 V square. Then we have to again arrange this equation. Then we get the K1 VI cos theta minus tau equals to K2 V square upon VI. Again it should be the cancel, and this VI is nothing but the Z, and we get the K1 upon K2 cos theta minus tau. So this equation of the circle having the diameter, that means K1 upon K2, it is passing through the origin, and this constant K1 by K2 is the ohmic setting of the relay. It is the ohmic setting of the relay. So we have to consider this Mho relay is located at the point A. Suppose there is the point A. This is the point A. Okay. So the relay operates only the fault occurring line A to B. So we have to consider this point M1 to M3. Okay. We have to consider the Mho relay is located at the point A. Suppose this is the point A. So the relay operates only the fault occurring line AB. So we have to consider the point so we have to consider the point A and B. So there is the point A and there is the point B. And it doesn't operate for the fault occurring in the AC. So there is the, suppose this, there is the C point, there is the one line, there is the one dotted line, and there is the point C. So we have to see that it doesn't operate for the fault occurring in the AC. So from this operation, it is clear that this relay is made inherently directional. So it is depending upon the directional. So the first sentence I was said, the impedance relay is not normally used because of need of the separate directional unit. So hence it is proved. Thank you.